Assalamualaikum warahmatullahi wabarakatuh. My name is Nura Fatih Ismahani binti Ahmad Idris and my metric number is 221302403. Alright, in this video, I will demonstrate about the data preparation and data pre-processing for a classification problem using a Python. So this demonstration will cover handling missing data, encoding categorical variables, splitting the dataset, and feature scaling. So for the first part, which is for the example, we will preparing the data for an AI model. So the first thing we do is import the required libraries such as NumPy, Pandas, and scikit-learn. And then I load the dataset from an Excel file, which is the name train, and will display the first few rows to understand the data structure. So I will display 5 first few rows from the dataset, the train. This is the dataset that we were talking about. Here we have in 107 datasets. So we will only display 5 first row only. Okay. So we will use this coding here. And while we wait for the output, we will separate the independent variables and dependent variables for the next step. Alright, here is the first 5 row values that I said that will display to understand the data structure. Here, this one. And then for the next step is separate independent X and dependent Y, right? So we assume as the last column, which is for the target, we will see on this CSV file, okay? For the target, the last column here, is a dependent variable, which is Y. So we will print only 5 row. For the X variable, we only print 11, okay? So you can see here, this is the X variable and this is the Y variables. So after we separate, I want to find a value, the missing value, that in none form. Like here, we can see here, this is none. The first one is here, and the second one we have is here in the different column. So I want to take out all the data about we have in the missing value. So for example, this row, I want to take out this row, and also this row, I want to take out this row. So these 2 rows, I want to print this only 2 rows, and I will use this code, which is from the file we got, like from this file, from the Excel file, we will print only none row. So this is the output that for the code. So when we found the none row, which is for the missing value, we will handle the missing value. We will handle these missing numerical values. We replace using min strategy here. Using a min strategy with simple imputer code. So when we use this, we can see the before and after we using the simple imputer. Like I said before, this is the before we use the simple imputer with a strategy min, right? So the after is like this, where we found the value the missing value for none that we got from here, like this. Yes, and this is the none value. Alright. Since the machine learning models work with numerical data, I encode categorical variables using label encoder. This is for the x variable part, and this is for the y variable part. So here we can see, actually if the label encoder, I mean the y variable, we don't have to print it out because all the values in the target column is 0, right? So they will we cannot see the what change in this part. So we can only use the for independent variable only, which is the x, like this. Then I apply the one hot encoder coding for convert the categorical features into the binary format. This one I make it as a general where everything here I will convert into the binary format. So this is the output here, and then we will split the data set into training and testing ratio. For this part, we use 80-20 ratio, which is for the training is 80% and the testing is 20%. Okay, when 100% is equal to 1.0, so we use the testing ratio, which is 20%, right? So it will be 0.2. And that is the output here. Okay, so I finally apply the standard scalar to the standard scalar code to normalize the features so that all values are on the same scale, like here. Okay, that's for the part 1. And for the part 2, for the exercise, we will implementing data pre-processing for classifications. Alright, just like before, first we will import the necessary library like NumPy, Pandas, and scikit-learn, and then we'll load a loan classification, load data file in the CSV use by display first 5 rows to understand the structure. Alright, so this is the data here. We have 102 data, as we can see right here. Okay, so I only want to take only these 5 to print out and show you guys how the structure works. Just like before, the coding is just the same, just change this read, this part, these two only. Alright, okay, here I can show you, like here, this one, you can see, right? Okay, then for the separating feature x and feature y, I assume the last column, which is the feature y, is a default risk, which is we call it as a target variable. Okay, and default risk is in the last column in the dataset, like this one. So the default risk will be stored in feature y, and this is how we will print it. This one until here is a feature x, and this one is the feature y. Okay. Alright, then we will handle the missing value, which is in the none form, that we assume in the income column we have that, and we will use the strategy mean, just like before, the mean strategy with simple imputed code to find the value, to find the missing value of the value in the income column. So this is what we found. Right, because of a non-value here, we have in this number 3, the data number 3 and the data number 19. So I will print the data in 20 rows. So as we can see here, this is the first non-values that we can get, and this is the second value, the non-value. Alright. So the next is we handle the categorical variable, which is the occupation features, to encode using label encoder. We handle that using the label encoder code. We only want the occupation column, occupation feature only. So I make two different solutions. The first one, I will just print everything except for the y variable, and the next one is only the occupation features. So how I make it? This I put an occupation, and then I will declare the occupation equal to 3. And why 3? Because 3 is the number of column we have in the data sets, which is the income is the 0, and because the array will start from 0, right? So the income is 0, credit score is 1, loan amount is 2, and occupation is number 3. So that's why occupation is equal to 3. And as you can see, this one is the normal coding for the print, and this one is I use occupation in that part. Okay, so the first one is we will get like this. As you can see, we print from the income into the occupation, but only occupation part we change it into the binary. This binary is followed by the alphabet, right? So the 0 is for A, which is for the artist, right? So we get 1 2 3 4, and it is 1 2 3 4, this one artist. And we don't have a B and C, but we have D. So D is the number 1. Let's check. See, like I said, D is number 1, and after D is E in the number 2. Is E for the engineer, and so on until the Z. Right? So for this part, I use occupation because I want it to print the occupation features only. So it will be like this. Only the occupation features. And the next step, we will split the data set into training and testing just like before, but in a 70-30 ratio, which is the training is 70% and the testing is 30%. And just like before, 100% is equal to 1.0. So the testing ratio is the 30%, right? So it will be 0.3, and we declare here. So this is the result here. This is the result after we split the training and testing. And finally, feature scaling is applied to ensure the better model performance by using a standard scalar code. Alright, so this is how it will look. This is we call it the final result, the final output after we apply the standard scalar code for feature scaling. Alright, so in conclusion, these data preparation and pre-processing techniques that I implement, that I use for example 1 and exercise, we can see that it's required. It's required before training a machine learning model, because without it, there will no training. Alright, so that's all what I understand, and it's fun. Okay, thank you for watching.